So my name is Brad Neuberg. I'm with Google's developer programs. Today I'm going to give an introduction to HTML5, and I want to encourage this talk to be interactive. If you have a question, if you have a rant, please raise your hand during the talk so we can answer questions or hear rants if they're short. So before I sort of jump into HTML5 proper, I want to set the context of sort of where we are today, why the arrival of HTML5 is exciting and interesting. I think it's no secret that the last 2 years have been a very interesting one on the web. Things are really accelerating. If you look at this graph, what you see at the top, the black line, is kind of the abilities of native platforms. And those have stayed roughly consistent the last few years. But over the last 2 years, really the web platform has kind of woken up again. It's a renaissance. And we see just sort of greater and greater and greater abilities in the web browser, really making it possible to build web apps that have almost the same degree of fidelity as native apps. And really, it's not that hard to imagine that soon those two lines will converge, and you can really start building web apps that are even more powerful than what we have today. And some of the new abilities that we'll touch on in HTML5, they're solving real developer challenges. One of the primary ones that I'll talk about is graphics. You know, people want to get outside of the standard text that you can do on the web today and do graphics. Location, it's a real challenge. People want to build location-aware applications, for example, for social networking and maps. Storage. You know, I like to say we've got these unbelievable machines now, and we're using them like they're a Commodore 64 in terms of the web. We don't really use their abilities. So when it comes to both storage and speed, in terms of JavaScript being much faster, let's take advantage of the machines that we have in front of us today. In terms of one of the real trends of the last 2 years is we have more developers when it comes to open source and alternative browsers. So just the last 2 years, if you look at the number of check-ins in terms of Firefox, Chrome, WebKit, you see a huge, huge increase in the number of active people actually contributing to these open source browsers. And then you see a massive increase in the number of users. So when Mozilla and Firefox first came out with an open source browser, I think it was an open question of whether you could build a consumer open source application. And I think at this point, the answer is yes. It's been a really sort of amazing thing that now you really can, users will use an open source browser. We're at probably about 30% in terms of the combined alternative or modern browsers, as we like to say. And that's a roughly linear trend, and it's only increasing. One of the other big changes the last 2 years is JavaScript has gotten much faster, about a 100 times increase in the performance of JavaScript. So this is opening up building more advanced applications in the browser, and I'll show you some later on some really cool demos of things like image recognition being done in JavaScript in the browser, and it's actually working. So this is really due to the fact that JavaScript has gotten much, much faster in the modern browsers. So all of these things come together. The fact that we're in a different world today than where we were in the late 90s when the last version of HTML came out. HTML4 was roughly around 1997. And the world is different in terms of some of the things you saw earlier. So it really is time for a new version of HTML to really rev things. And I want to just sort of touch on something. It's been really amazing what folks have been able to do the last few years just using the latent abilities of the browser. So I'd like to ask, when were the basic technologies behind Ajax invented? I mean, the answer is up there. It's actually a little earlier. 97. And where? 97.
97, 85.
Did it come in 95? Well, it showed up. Okay.
I was teaching then.
So what was the first application that used the XML HTTP request object?
Outlook, web-based Outlook.
Outlook Web Access. I heard from two people. That's right. So that was the first app that really used was really pushing dynamic HTML, XML HTTP request, 1997. Unfortunately, it took about 8 years until about 2005 for it to show up in enough browsers for developers to sort of become aware of the fact that, hey, this stuff is everywhere. Many people in 2004 were saying dynamic HTML is dead, if you were sort of a part of this, and suddenly people realized, no, you can do really amazing stuff. And that renaissance kind of began in 2005. So this time around, we have a chance to do things differently. We have a chance to kind of consciously say, what do we want from the web? Let's rev it, and let's move forward. So the talk today is going to be broken into several parts. HTML5 has a lot of stuff in it, and we would be here the whole day if we went over all the different things. So I'm going to focus on a few pieces that are really interesting. We're going to talk about graphics in the browser, and I'm going to talk about the canvas tag and something called SVG, or Scalable Vector Graphics. We're going to talk about video in HTML5. I'll talk about the geolocation API. I'll go into something called the app cache and the database, and then something called web workers. And for every one of these, I'll give a basic introduction, demos, some sample source code, and then I'll talk about where can you use this today. Where can you actually deploy this? So jumping in, let's start with graphics. So until recently, you really couldn't draw on the web very easily. And you could use things like Flash and things like that to draw on the web, but they didn't integrate very well with the web stack. And even if you could get some images on the page, you couldn't make them very interactive with JavaScript. It was pretty basic. And there are a variety of options that are present. You could use vector markup language on Internet Explorer, Flash, and Silverlight to do these things. But these are kind of trapped in a box. They don't integrate that well with the rest of the web technologies, HTML, the DOM, CSS. The nice thing about Canvas and SVG, and I'll give a basic introduction to both, is that they integrate as first-class citizens with the rest of the web stack. They're not trapped in a box. And I'm going to talk about both. I want to talk about SVG first. SVG is like HTML for graphics. It's been around for several years. One of the things that's happened in the last 2 years is it suddenly showed up. It's on all the browsers except for Internet Explorer. Not casting any aspersions there, but it's finally at a state where people can start to do interesting things. It stands for Scalable Vector Graphics. And just like I said, it's like HTML. HTML, you've got a form tag. You have a table tag. Well, now you have a circle tag and a rectangle tag. So let's look at an example of this. This is to draw a rectangle. You say rect. Put it on the screen at some location. Give it a width and a height. Give it a fill and a stroke. Change the outline. And then I love this. This right here makes the corners rounded. So that's all everyone jumps through hoops to do rounded corners on the web. But that's how you do it with SVG. Yeah, so that you could make differing kinds of rounded corners. That just makes them the same. And this is the part that's interesting. We can set an ID so that JavaScript can interact with this just like you do with HTML, and a class. So you could centralize your style information using CSS. And that right there is what is drawn from what you just saw. The reason I bring this up today is because one of the cool new features of HTML5 is that it now allows you to drop SVG into normal HTML pages. So right here, the first thing you see is you see that doc type at the top. That is the doc type for HTML5. When you drop that into one of your pages, that tells the browser this is an HTML5 page, and use the HTML5 parsing and abilities. Then, one of the new features of HTML5 is SVG becomes just a part of HTML. So there you see us dropping the rectangle right in the page, and you just surround it with the SVG tag. Very excited. Here's what's cool about this. SVG, years before this, you had to use XHTML, which I don't like getting into big discussions about XHTML versus HTML, but let's just say it's not used on 99.9% of the web that's out there. The nice thing about this is you can now drop it into normal HTML pages and just get graphics done. So the question is, what's going to happen with all the previous versions that don't support this? So, what do you mean by previous versions?
Support would put namespace.
Yeah, so
SVG, the namespace, because it renders as separate.
So the comment was you could put namespaces on the SVG. So with HTML5, you don't have to put the namespaces, but you can put them on there if you want to work with browsers that might exist before this parsing algorithm. So I mentioned that what makes Canvas so cool, what makes SVG so cool, is it's a part of the web. And so here we are grabbing the rectangle off the screen using normal JavaScript, using just like we would with HTML. There we are changing the color. I mean, you don't have to learn significant new skills. There we are making it be interactive. So when you click it, we say hello. And one of the things that's unique about SVG, it might be a little bit hard on here, but on the left you see a bitmapped image. It's blurry. On the right is a vector image. So whether you're looking at something with SVG inside of HTML on a 40-inch monitor or a small iPhone screen, it's going to look legible. It's going to look beautiful. That's one of the nice side effects of vector graphics. Yes?
Can you apply CSS styles to the objects?
So the question is, can you apply CSS styles to the objects? Yes, you can. Something really cool about that. So we did an experiment where we took one of these New York Times infographics. You know, you see an article that says, you know, how many people think blah. And there's little graphs in there and text. That was a 50K JPEG. We turned it into SVG, made some CSS so you could centralize, you know, all my bar graphs look like this, all my styles look like that. What do you think the size was of the SVG file using CSS with gzip compression on?
You mean the source file or?
The source file, like that you would end up serving to someone.
Smaller because you're reusing it.
So one comment is smaller because you're reusing it. It's definitely smaller. 4K, 1K. 1K. Actually, I think 1.5K. So about an order of magnitude reduction in size. And using CSS can help with that as well. So the Canvas API. The Canvas API, I like to think of that as a scriptable image tag. Instead of having to always give the source of what you're looking at, you can draw your own image. And you predominantly drive it with the JavaScript API. To use it, the first thing you do is you drop the Canvas tag into your page, you give it an ID, and you set a width and a height. Then, in your JavaScript, you grab a handle onto your canvas, and you get what's known as a context. And that gives you a drawing surface. And so you see the 2D there. I always love that because that opens up the possibility of a 3D drawing service, which has begun to emerge. I think WebGL, which is already just arrived on the builds of Firefox and Safari. Yeah, Firefox 3.5 ships with it. I think Firefox 3.6, I think, has this experimentally. But you can say 3D, and then it hands you back a drawing surface where you use something like OpenGL. But that's not part of HTML5. That's something else. HTML5 gives you a 2D drawing surface. And then once you have that drawing surface, you can start to do things. You set your fill style, your stroke style. So here we are changing how things are filled. And then you could reuse that. Here we are doing a rectangle. That's just saying X, Y with height. Here we are changing the style again, but adding some opacity. So that's an RGBA. So make it 50% opaque. And then we're drawing another rectangle. And then you get, that is what that results in. So it's a really straightforward API. It's really nice. I'm going to touch on when do you want to use one or the other, but I want to show you demos first. This is the Firefox, the Mozilla Download Center. I really like this one because it shows how to use both these technologies together to take advantage of their strengths. This page shows in real time people downloading Firefox all around the world. The page keeps a persistent connection open to the server and shows a yellow dot wherever someone's downloading. Here's what I love about this. The map in the background is SVG. That makes a lot of sense. They probably grabbed the map from Wikipedia, which has a huge repository of these, and they brought it into the page. The dots are drawn in real time with JavaScript using Canvas. So I like this. It's a nice integration of the two technologies. This is a really creative use of the Canvas tag. Everyone here has played Doom, or a first-person shooter. This is a first-person gifter. So this is a great use of the Canvas tag. You might not be able to notice, but I'm using the keyboard to do the navigation. This is a performance-sensitive application. I'm not using the mouse. Canvas is especially suited for games.
So that's a 2.5D, right?
Yeah, so they're faking that. They're faking this. And so they're probably using what's called draw image and changing that based on the perspective and applying a transform. So I've got some special demos I wanted to show. I went to a conference this last weekend, and Vincent Hardy showed some super cool demos that were using YUI 3, where he slightly changed it to work with SVG. And he took all of the YUI 3 animation functions and then applied it to SVG. And I was really blown away by these. So I want to show you two of these. I got permission from him to show them to y'all. The first one grabs images from Flickr. So all of those transforms are being done by the YUI 3 transform functions, but it's applying them to SVG elements instead of HTML. And then as we go over, this is taking pictures from the Flickr the interestingness feed.
Is done in SVG.
The question is, the scaling is done as, yes, all of the scaling is done with SVG.
Which one is the canvas part?
The question is, what's the canvas part? This particular one is just using SVG.
Oh, okay. Wow, it's fast.
So everything you're seeing here works on Firefox, Safari, and Chrome. And this is a nice use of SVG. I'll touch on these. It's mouse-driven. You're doing scalable transforms of things, rotations. This is a good use case of SVG. The question is, what kind of CPU do I have? That's a good question. This is not a particularly new laptop. It's several years old, Intel.
Core 2?
Question is Core 2. It probably is. Here's one more. So these are animated lyrics. This is, again, all done with SVG. Also using HTML5 audio in the background. What you're going to see a song, and you're going to see lyrics that are queued to the song. And all the lyrics are just plain text, so they could be translated in real time. We're not doing that here. And you'll see, oh, is my sound on? Yes, this is using Smile. The question is this using Smile? It is using Smile. Smile allows you to do animation with time sequences. And again, actually, I need to check. I'm not sure if it's using Java, because I think this works on Firefox as well. Here's another really, really cool use case of the canvas tag. This is called Bespin from Mozilla. Here's the thing I love about this. The folks at Mozilla wanted to create a really world-class code editor, but in the browser. And they needed to work around, they didn't want to have to deal with the text area element. So they built everything to just go through the canvas tag. And they built a full code editor directly in the canvas tag. So it has collaborative editing and so on. But I love this because they forced everything through the canvas tag, do some really nifty stuff. So a natural question is, when Canvas or SVG? So SVG is higher level. When you draw something on it, you have a tree. When I draw a circle or a rectangle, the computer still knows, hey, that's a circle, that's a rectangle. And that's either something that helps me or it's something that hurts me, depending on what I'm trying to do. If I want to know what things are on the screen, and I want to have mouse interaction, for example, then that helps me. If I want import and export, I can use Illustrator to import and export this. You can use Inkscape, which is an open source tool, to import and export. Then that makes sense. Canvas is lower level. If I just want pixels, if I just want a scriptable image tag, keep that in your mind, then Canvas is the right way to go. Generally, you'll know, do I not need to know where everything on the page is? Do I have 10,000 bouncing balls and I don't need the computer to know, hey, each of these is a bouncing ball? Canvas makes a lot of sense because then I won't have the overhead of keeping track of where everything is. So if you have a lot of animation, if you're JavaScript centric, if you're more pixel oriented, so you don't need things to dynamically scale based on the size, you can force each of these to do what the other does. I like to say, like, as computer developers, it's like a linked list and a hash table. You can force one to do the other, but they're better suited for different tasks. So you choose the right tool for the job. You can force Canvas to do what SVG does, but you'll end up recreating everything that SVG does, and vice versa. If you're building a side-scrolling game, you shouldn't be using SVG, you should be using the Canvas tag. And the nice thing is that HTML5 gives you both of these options for different kinds of use cases.
So generally, a canvas has lower resource usage, right?
It's roughly 20% faster because it's not keeping track of where everything is on the page. If you end up recreating all the infrastructure to keep track of everything on the page, you'll probably slow it down by about 20%.
How about memory usage?
So the question is memory usage. By default, because you're not keeping track of everything, Canvas would have lower memory usage. But if you started doing edge, if you started actually having objects, so again, it depends on your application. Actually, you had your hand first, yes. You did, yeah.
Can you talk about these two different presentation techniques in terms of accessibility?
So the question was talking about these in terms of accessibility. Okay. As defined, SVG is more accessible, potentially. It's markup just like HTML. It has a title element, a description element. It has accessibility baked in. None of the screen readers currently hook into that accessibility. But when they do, if you create content, it will be accessible. Canvas is currently just a bunch of pixels. There's no current accessible mechanism, but there's a lot of discussion happening and brainstorming happening about how can we use Canvas and make it accessible. So I think at the end of the day, both are going to be roughly accessible, but the screen readers need to catch up.
I suppose anyone who likes DOM manipulation would like SVG.
Yes, so people have added there's jQuery bindings on top of SVG, so it looks and feels just like jQuery. That's right, SVG is like HTML. It's markup, it's got a tree.
So you do write API.
Yeah. So where are these supported? Both Canvas and SVG are supported on all the modern browsers. The direct SVG, I love that. It's like this. I know it's like a little passive-aggressive term. The direct SVG into HTML syntax is still being finalized in HTML5. So Firefox 3.6 will have this, but that's still coming down the pipe. But raw SVG support, as you saw, is in all the browsers, as is Canvas. We don't have a lot of time, but I want to touch briefly. So how do we get Canvas to work on Internet Explorer? How do we get SVG to work on IE? There's a really nice JavaScript library called Xcanvas, which can help you run the Canvas tag on IE for certain use cases. And I've also been working with other people in the open source community to do the same for SVG. We've got a library called SVG Web. It's currently in alpha, which gives the illusion of native support for SVG in Internet Explorer with no downloads by the user. It's just a JavaScript library. I got a short video here. It's a 1-minute video where I will, with house music, of course. So there's nothing to download. It works on almost 100% of the browsers out there. Here we see native SVG in Firefox. And then we look at Internet Explorer, it's IE7, and it works with the same fidelity.
Is it using the VML?
I'll touch on how it works in a second. So it's not just static, but it's scriptable SVG as well. We've also got basic video and audio support. This is IE again. What's called declarative animation, so you can make animation easily. We've got fonts. We've got that resolution independence, so you take advantage of the size of the monitor. And that's like a little basic Tetris game. So the idea here is the library will use the native support when it's present on all the other browsers, and then we'll do this magic on Internet Explorer, and that's where you can grab the alpha currently as a developer. The magic, I like to say you want the blue pill, the red pill. So the blue pill is the developer you feel like you've got native support. You can script it with JavaScript. You drop SVG right into your HTML page. The blue pill is we use Flash to do the rendering. Because we have it on wherever IE is, we know that Flash is going to be there about 97% of the time. And then we use something else called Microsoft Behaviors. But the developer doesn't have to know this. It just looks and feels like there's native support. And the user doesn't have to download anything. And the whole goal of this is we go from about 30% SVG support to close to 100% to help developers actually be able to create stuff. And this last weekend, we just hosted the SVG Open Conference at Google to talk about some of this work. And we've been working with Wikipedia as well, who have 250,000 SVG images, all under Creative Commons licenses, which can be really cool when you're building apps. And we're working with them to get them displaying on IE using this stuff, and doing some cool stuff. So you've seen graphics, yes? So the question is, what are the Google properties that are using SVG in Canvas? SVG is used in Google Docs when you drop an illustration into the page. It's also used in the Google Visualization API for some of the APIs. The Canvas tag is used, what's that?
Google Maps use for polygons, polylines for small.
Google Maps actually has some complicated switching where depending on the platform it's on, it will either use Canvas to draw polygons. Yeah. They didn't need the overhead of SVG for their application. They just blit out raw polygons using the Canvas tag. And they have to use VML on Internet Explorer. Let's see. There's a lot of sort of developer tools and graphing tools. There's something called the Performance Understander, which uses Canvas to do all sorts of cool graphing in real time so you can see the performance aspects of your application. So good question. So let's look at video, HTML5 video. I like to say it's 2009. It's clear that multimedia is here to stay. It's clear that video and audio is here to stay. Again, this should be a base part of the platform by this time. One of the cool things about HTML5 is just like, imagine if in the late 90s you had to have used the object tag to embed an image. Yeah, you laugh, right? The same thing's true with video. Video is becoming so common on the web. It's easy to produce. It's easy to host now. It's time there was a video tag to match the image tag. HTML5 has a video tag. You just use the video tag. And then you have something roughly similar to setting the source to where it is. So I'll show you how that works. So the most simplest is you say the video tag, set the source to where your video file is, and then you can drop the attribute controls on there, which will cause the browser to drop a little set of play controls for starting and stopping. And on the inside, you can drop fallback content that will get displayed if the browser doesn't support. So you could fall back, for example, by dropping a Flash object in there. So for browsers that don't have the native support. The video tag really starts to shine when you're dealing with scripting. And I'll show you that. One other thing I want to show you is you might have multiple versions of the video. And unfortunately, the situation on the web right now, the formats for video are probably going to converge on what's called OGG and H.264. And generally, you'll have to throw up two versions. And here's how you can point to both. There we point to the OGG version and then the H.264 or MP4 version. The cool thing about the video tag is it has a whole set of ways to script it. Here we are grabbing it off the page and then playing it. But there are callbacks, so you can get called back as the video plays. So you could synchronize and queue changing your user interface. Maybe this is a video showing an historical timeline on Wikipedia. You could change the UI to kind of fade in and out different bits of information. So you can really, that's what I meant, you can break outside of the box that we've had before. Let me show you some demos. This is the basic player. It's a promotional video. Now, here's the cool thing. We can break outside the box. So that right there is just having CSS animations or CSS transforms applied to it. This is a mock-up of YouTube using the HTML5 video tag. So this video right here is directly being served to you without a plugin.
Welcome to the O3D Beach demo.
And each of these little thumbnails right here is the HTML5 video tag. And all they have an on mouse over, on mouse out. And you can imagine, the on mouse over just says play, on mouse out says stop. And I want to crack this page open because the nice thing about this page is it's using a lot of HTML5 features. So it's a good sort of example of HTML5 in general. So we see the HTML5 doc type at the top. Then we see one of the new HTML5 tags, header. So header just says, this is stuff at the top of my page. And there we drop our header in.
Does that scroll independently? Or does that position independently of the scroll?
So the question is, does that scroll independently of the page? Not by default, but you could imagine some CSS that says header position : fixed. So by default, some of these tags don't have any native browser behavior. They're just a better way to structurally say, here's what are actually the things on my page, which will make search engines' jobs easier, which will make reading data out of the page for sites kind of mashing each other up easier, and it makes, frankly, authoring easier. We've got the nav tag, which, as you imagine, basically is where you would put your navigation for the site. And then we have the article page, which kind of cues and says, hey, here's where the real content is. Everything else is just kind of Chrome, essentially, surrounding my article. Again, something that can help search engines, something that can help a browser, for example. When you zoom, it would just zoom in just to show the article. So browsers could start taking advantage of these tags. Articles are composed of sections. So here we are with the main content. That's the large video. And then there's where we see one of our video tags. That's the main one pointing over to the large video. And you see a property there that says auto buffer. Here's what auto buffer does. Even before you press the play button, that tells the browser, hey, go ahead and download this in the background and have it buffered. So when the user actually starts playing it, it'll start instantaneously. So that's what the auto buffer property does. You see the progress tag. This gives you a progress indicator. And right there's value. That's where you could set that through script. And the browser will style that for you. So you could imagine calling that with an interval as things get loaded. Here's a meter tag. So having 5 little stars, for example, that a user can grade, that's everywhere. That's what the meter tag does.
Can you do time sequence with the time tag?
So the question is, can you do time sequence?
I saw a time tag.
Oh, yeah.
You said just static time?
Yeah, oops, I missed that one. Thanks. So the question is the time tag.
Or it has duration?
Yeah, so this is another new tag. This just marks up when you have time in your document.
So you can just use JavaScript to do dynamic sequential.
So these are some of the other sort of tags that come along. I'm not going deep into these. Dialogue tag. That is, you could surround that around comments, for example. So at the very end, there is a footer tag, which is roughly similar to the header tag. So pretty straightforward.
Super search engine friendly.
Yeah, so the comment is super search engine friendly, yes. And also friendly for content management systems, for example.
What advantage does the time tag have?
So the question is, what advantage does the time tag have? So all of these tags were derived in an interesting way. Ian Hickson got a dump of the whole web and created a script that could determine what were the most used class names, the most used CSS class names. And they ordered them by, they were words like footer, header, time, article, section. And that showed, there's a theory called pave the cow paths, right? You don't, and some developers will do this. Like you make a neighborhood, you don't pave anything, and you see where the grass has been worn down. And then you come back a few months later, and that's where you lay down the sidewalk. That was like a cow path. It said, hey, people are actually marking up most of their pages with footers, headers. So we want to make the web easier to use for newcomers who arrive and more straightforward. So let's solidify those into actual tags since they're already being used, and they're going to make your CSS, for example, more readable if I can just say style of footer if something's inside the footer. Yes?
For things like time, is it like VCal where you have textual content and then there's a machine-readable representation and an attribute?
So the question is time like VCal where there's a human-readable and then a machine-readable?
Yeah, the content of the element is human-readable. You have an attribute which allows you to attach a machine-readable form to that.
So the comment is essentially both human-readable and an attribute for machine-readable. The time tag itself has been in a fair degree of flux. I haven't looked at the latest representation. My understanding is it's generally to mark up a human readable, and you can provide an optional machine readable. It's not meant, time gets complicated really fast for anyone who's done internationalization. It's meant to hit the 80% of time and not turn into an ugly monster spec itself, which can happen quickly. So I don't know the exact state, but I do believe you can put a machine readable representation in there. One more question on this, because we got to move along. Yes?
So are header and footer like semantic tags with the same block style like divs, or do they have an impact on the visual representation? For example, what if I'm trying to put a footer at the top of my page? Does it just render as a block level element and then have a semantic impact, or?
So the question is, do footer and header have any visual impact, essentially, on how they're rendered? They're essentially block-level elements currently. Footers used to be treated a little differently, but that's been cleaned up in the spec based on feedback from visual designers. Right now, they're kind of visual neutral. They're like divs, essentially, and you would have to apply styling. So let's jump on, because we got other areas. The video tag is in all of the modern browsers. That one wrinkle is they support slightly different codecs, but that's essentially at this point 2 different codecs. So it's probably going to converge on both of those in terms of what folks have to support. So geolocation, this one's really exciting. Geolocation, once you have that on the web in a secure way for users, there's all sorts of interesting stuff you can do. I'm waiting for someone to really integrate this really deeply in a good way for social networking, obviously for games, for photos. I think people are going to do stuff with this that are unexpected and very surprising. And the cool thing is that browsers are now location enabled. It's on the latest version of the iPhone. It's on Firefox 3.5. So it's in enough areas you can start doing really interesting stuff. And I like this one because it's really straightforward to use. You get the navigator object has always been a global object. You get a new object called geolocation. And you have a method called getCurrentPosition. That method takes a JavaScript callback that will get called with a position object when the position has been determined. And browsers can do it in different ways, but many times they'll kind of ask, do I have GPS? Use that. Do I have Wi-Fi or cell phone tower triangulation or reverse lookup? I'll use that. But the developer doesn't have to know those details. They just get a location and an accuracy. They get back this position object, which has a lot of stuff on it, so you can go pretty deep. But at its basics, you can grab a latitude and a longitude. And then, for example, here we are. You could call some method that you've defined called showLocation, which would draw that on a map. You could get, like I said, the accuracy, so maybe draw a circle around that to kind of show, here's how sure we are about your position. So that's a really straightforward API. Here is a demo of Google Maps using this. Again, this is just a prototype. The first thing you see is a gold bar that says, hey, this page wants to know my location. And I could make it permanent. We'll make it one time. And then it figured out my location. And then mapped it on the Google Maps, using the Google Maps API. So it called geolocation, got back that position object. That's a really good question. So under the covers, not GPS. I don't have that on my computer. Obviously not cell phone ID. Using a Wi-Fi database that Google makes available for free, that Firefox taps into, which can reverse an IP address into a rough location.
So I noticed if I hook up to a wireline, it just say plus office skills.
That's right. So at that point, the last fallback you have is IP address, reverse IP address lookup, which is very rough-grained. Good question. Yeah. It can be surprisingly good or wildly bad. Luckily, it's never blown up for me on a demo. No. This is supported on all the modern browsers. It is not yet supported on the desktop version of Safari, only on the iPhone version. All right, let's look at the app cache and the database. Both of these work together to let you build offline web applications. So if we want web apps to really be able to be the place that we do work, they need to be able to work on airplanes, when the internet connectivity is sluggish or slow, when you go to a conference and suddenly the Wi-Fi drops out for several hours, but there's still a presentation you need to give. A lot of people say, why do I ever need offline? You need it when you need it, right? I mean, you will sometimes have troubles with the network, and that's when you don't want to be locked away from your data and your apps. So the database and the app cache, these work locally to let you build offline web apps. And let me show you a demo first of these working together. This is a sticky note demo. You can put sticky notes in here. Like the nice. And then if I quit Safari and then come back, they're still there. And I like this. This little swoosh. That is called a CSS animation. It's a nice little effect. So what's going on here? The app cache, if you want to build an offline web application, you need two things. You need to be able to have your user interface when you're offline, your JavaScript, your HTML, your CSS, and you need to be able to have your data, the user data. The app cache is the first part. I like to think of this as a super browser cache. Why do you think we can't just depend on the browser cache? Like, why couldn't I just kind of fiddle around with the browser cache to try to get my stuff to be there when the user goes offline?
It's ultimately up to the browser.
What's that?
It's ultimately up to the browser.
It's ultimately up to the browser? Yeah. So you can't really depend on the browser. Things could time out. They may not be in there. They may have gotten thrown away. Maybe the user never went to that part of the user interface. Maybe it's a dialogue that needs to show up later. The app cache is a simple file where you list all of the resources that you want to have be offline. The first line has to be the magic words cache manifest, and you have to set your web server to serve it up with a special MIME type. Inside of there, you list all of your resources, and then on the body tag in your HTML, you set the manifest attribute to where this file is. And once you do that, the browser will prompt the user, can you take these things offline? And then we'll download all of these resources in the background, and we'll periodically go back to see if that file has changed so you can update and version your application. Is there a size limit? There is. Let me think. I think that the HTML5 spec recommends. I know there's a recommendation. This number keeps changing. I think last time I saw either 500K or 3 megabyte recommendation for the database. I can't remember if there's a limit for. That's a good question.
If
For,
Binary data?
can there be binary data? Yes, there can be binary data.
Doesn't depend on current network loading. So
What's that?
will it load all the stuff when network is too low? For example, slow connection.
So the question is, will it load all this when the connection is slow? That's right. You don't have a lot of control over when this is loaded. That just tells the browser, here's what I need to be offline, and the browser will make these resources available offline. But on a slow connection, it either grabs them all or it doesn't. So you don't end up in a halfway inconsistent state.
Do these resources need to be served with some kind of particular cache headers?
So the question is, do these resources have to be served with a particular kind of cache header? No. They don't need to necessarily be using HTTP caching, but that means that the browser will think they always change if you don't. I mean, you probably... Okay, so I don't want to get deeply into the algorithm. It's a little complicated. But what the browser does, if it wants to know if anything's changed, it first looks at the cache manifest and says, has this file changed at all? If the file's changed, then it goes and revalidates every single one of the resources. Because that's so things are efficient. Right? So you can do comments, for example. So you could have a comment that says version equals 1. If you just bump that up, the file will change, and that will tell the browser revalidate all of these. And then it'll revalidate them, and if any of them have changed, it'll re-download those.
Is there any mechanism to make sure that if you have a version of a file from an older version of the manifest, it won't be loaded into the application with a version of another file from another version of the manifest? Is there any kind of atomic switchover from one downloaded manifest to another?
So the question is essentially, is there sort of an atomic update? Yes, there is. Because a lot of this was written with the feedback from the Gears team, who needed to do these kind of things for offline Gmail and needed atomic updates. We got to move on. The other half is the database. This is a full SQL database, generally using SQLite in the browsers that support it. Again, it's pretty straightforward. You open your database, give it a name, a version for schema migration, if you ever need to do that. You give it a name that will show up. Some tools like Safari 4 let you browse all of the local data. That's the name that will show up. And then you can give a suggested starting size. So right there, we're asking for 200K. So the user will be asked, do you want to give permission to store this? You want to ask all at once so the user isn't constantly pestered. So we're saying we're probably going to use a total of 200K here. Just ask the user one time. Now let's look at an example method. You saw those post-it notes. Let's say we want to save these and make them persistent in the database. Generally, we would probably be saving an ID, some text, a timestamp, where they are on the page, and a z-index, because you saw they were stacked. Let's see how you would save that. The first thing you do is once you've gotten your database object, you ask for a transaction. Whenever you're working with the database, everything has to be inside of a transaction. The reason is the web is an incredibly unforgiving environment. If you're doing, as you'll see, we'll be running SQL here. You want, if the user closes their browser, leaves the page, the browser crashes, you want to make sure things are still solid in your database. So whenever you touch the database, it's all inside of a transaction. So things either work or they're not applied. So the first thing you do is you say, give me a transaction. And you give it a JavaScript function. The transaction is handed to you with a callback. And then you start executing your SQL. And we use normal SQL. Here we are inserting into a table called WebKit Sticky Notes. There's our columns, which pretty much map to what we have up there. We give our values with the question marks, and then those get filled in. I always like to ask, why do you think we use the question marks instead of directly building up a giant string there and pasting them in? One answer is injection attacks. So injection attacks are not a concern on the client side because you need to treat everything in the database as untrusted. When you replay this stuff from your database back to the server, you shouldn't be trusting that input just because it comes from the database. You should be rerunning it through whatever on your server side vets input just like a user added to it in their form. So on the server side, we do this for injection attacks. On the client side, the primary reason is, what if one of the values has a single or double quote in it? Basically, that makes sure that things get encoded correctly. Because if you have a big string and a user enters a double quote, it'll break that. So it's basically there as kind of a convenience. So you don't have to build up a giant. The code would be kind of unreadable if you build up a giant string.
Can be sent manually.
What was that?
I could mimic that and send it manually without a browser to the server if it's not server validated.
Yeah. Well, okay. The comment is you could do this manually if it wasn't server validated. Is that correct?
Yeah.
Um,
And I could.
SQL doesn't let you do that. Doesn't open that hole. I mean, that's just, you can craft an HTTP request.
yeah, that would be outside of the standard.
Nothing new for that. But I disagree with the
But
assertion
I
that
see what.
I disagree with the assertion that SQL injection isn't a problem.
It-
You can turn SQL injection into an XSS if, for example, something is taking JSON out and evaling it. So
That's a good point.
SQL injection, in that case, you're laundering.
That's true. So I should take this. A lot of people commonly ask, what's the security of this?
It has to always be validated on the server side regardless.
Well, you need to protect yourself against cross-site scripting attacks in general. All of these use the same domain policy, so only the site that dealt with something can write to it. But if you pull in JavaScript from all over the web, that has access to the database. So you need to make sure you don't have cross-site scripting attacks. If you're getting data from a third-party source and you're bringing it in, that would give you susceptibility to a cross-site scripting attack, just like pulling in arbitrary JavaScript. So that's a good point. So you do need to be aware, but only because you need to be aware of cross-site scripting attacks in general in web browsers. And especially now that you're like if you pull something from a cookie, it's the same kind of issues. So again, this doesn't introduce new insecurities. You just have to be really careful about the existing cross-site scripting type attacks. That's a very good point. The HTML5 database is supported everywhere. Unless this has changed, it's currently on Opera Mobile but not desktop. It'll be in the next version.
Of the desktop?
Yeah.
11 then?
5, I think.
Oh.
So we only have a few more minutes. Let's jump to web workers. So now that we have all these utilities, we got a lot more JavaScript running in the page. And with great power comes great responsibility. You can now really easily hose the browser. Most browsers are written such that the JavaScript runs in the same thread as the user interface. So if the JavaScript is doing a lot, the browser locks up, has a bad experience. So web workers let you make some JavaScript that runs away from the browser so the browser can stay responsive. And let me show you. It's not quite threads because threads are kind of complicated in JavaScript. It's message passing, and I'll go through the API. But you basically give them a message, they run, and then they come back and give you a message. Let me show you an example first. This is an example that finds prime numbers. When we press go, nothing happens. The browser completely locks up. This is, by the way, not using web workers, traditional. Nothing happens. I have to literally kill the browser.
Circular reference.
Now, if we run it with the good one, we press go. We see results coming in from the web worker. The browser stays responsive. It's supposed to stay responsive. And so the numbers continue to come. So I could continue browsing, for example, and so on. And on machines that have multiple cores, it'll be using your other core. Now let's put these pieces together. It's not too often that you want to find prime numbers, unless you're doing cryptography. This is a demo that combines a lot of the pieces you've seen. You're going to see HTML5 video playing. Let me just get through this. You can see HTML5 video playing. You're going to see a web worker that's running and using the fact that you can request every frame of your video and bring that into the canvas tag. Okay? It'll get the raw data. It'll process over in a web worker who is moving on the screen, send the results back, and then use the canvas tag to draw where everyone is on the screen. So those boxes are drawn dynamically. So JavaScript figured out where this person is. So whenever she moves. Again, web workers are doing that with JavaScript in the background. Whoever would have thought you'd see motion video detection in JavaScript on the client side? I wouldn't have. I thought you would be crazy if you told me that. Let me quickly show you what the code looks like. You put all of your code that will run on the worker in a separate JavaScript file. And you instantiate it like this. Once you get your worker, you give a message handler that will receive the results whenever the worker messages you. So this method right here will get the results. And the data is held in the event object as .data. Over on the worker side, we first have, let's say, our algorithm, like finding prime numbers. We start it up, and you get a magic method called postMessage. Actually, it lives on the window.postMessage. And that's where you can, as you have each of your results, post them back, which will go back to the listener function. So as each of those primes came in, we were just putting them out on the screen, or you could imagine the results of analyzing the video. People commonly ask, what can you do? On a worker, you can't touch the user interface, because then you'll hit the main thread. But you can do XML HTTP request. You can touch the database. You can do quite a lot on the workers. Again, these are supported by all the modern browsers. They're currently on Opera Mobile. Are they in the next desktop version of Opera? This brings us to the end. Do I have time for 2 more questions? Or, yeah? If you want to download everything you've seen today, there it is as a PDF. Does anyone have any questions?
How about cross-site XHR?
The question is about cross-site XHR.
Header permission based.
Header permission based. HTML5 has a way to do messaging between domains that Internet Explorer 8 actually supports.
How about the,
And actually, Facebook does use that.
how about the other browsers?
It is an IE8.
I think Firefox 3.5.
I think Firefox 3.5 supports it. I'm not sure if it's in Safari 4 yet.
How about Chrome?
Well, Chrome tracks Safari, so if it's in WebKit, it's either there or not. I'm not sure. Let me get some questions in the back. Did anyone have questions in the back? Yes?
Some of your demos were in Safari, others were in Firefox.
Yeah.
Is there a reason that you did that? Or
So some of my demos were in Safari, some in Firefox. I was cheating. The YouTube demo, for example, uses H.264 encoding. So that only works in Safari 4. But they could have written that to also serve up OGG versions that would work on Firefox. Certain things just work better on Safari. It's a little faster for some demos. The Firefox 3.5 demo, that was mostly because of the codecs. And Safari has the fastest. Actually, Opera and Safari might be neck to neck, but Safari has the fastest SVG support. So that's why I showed those demos in Safari. Yes.
real quick, you talked about a video tag. Is there also an audio tag?
The question is there an audio tag? There is an HTML5 audio tag that works similar to the video tag. You can take a look at it. 2 more questions. Yes.
What about the considerations for file sizes? Are the videos streaming?
Uh,
Do you put anything up there?
So the question is considerations of file size. So currently, streaming generally requires server-side support. At this point, that's out of the HTML5 spec, and the browser would just go and try to fetch that codec. And currently, it's just it just grabs the whole thing, but a particular codec could allow you to show some of the video before it's all downloaded. That's generally fake. It's faking streaming. I believe some people have been talking about formal streaming. It's a little bit outside of my domain. I've just kind of been a little bit aware of it. But some folks have talked about formal streaming on the HTTP standard that's supported. Yes? You had a question? Did you raise your hand? No?
So that means that there's no seek capability in the video tag. You can't suddenly say start playing from this portion instead of...
So the question is seek capability. That's a good question. So the seek capability can be from streaming. It can also, you could also imagine doing a range request using HTTP to do seeking. I'm not specifically clear if OGG or H2. I'm sure that H264 probably supports that. You know, HTTP can say, give me just this byte range. Again, I haven't specifically looked at that. If you have an answer, it'd be interesting to learn if you can look that up.
You kind of answered it by saying that there's
the capability.
no streaming, nothing there besides just purely playing the video. So.
Yeah, and again, if you have what are called range offsets with HTTP, that would require the server side to support range offsets. But that is technically a part of the HTTP standard.
Well, for to work with something like H264, you have to hit on an exact keyframe or something.
Yeah, yeah. I know there's work being done in this area. I've seen it go by, but I don't know the specifics. But that. That's right. So there's a question about keyframes. Keyframes can fake this. You can set the number of keyframes for a particular video to some granularity level that allows someone to jump around. I'm sure that OGG supports keyframes. I'd be surprised if it didn't. One more question. Or not. Thanks, everyone. Oh, yeah. Thanks.